Ladies and gentlemen, I present to you Chief Executive Officer and Chair of the Board of Mentor Graphics, Dr. Wally Rhines.
Thank you. So thank you very much. Very good to be here tonight to talk to you about something I've worked with most of my professional career, and that is silicon. Now, in high technology, buzzwords come and go very quickly, and there have been a lot in recent times. So think, for example, about the cloud. This is the number of articles published about the cloud, virtually unknown 10 years ago, and now 70,000 papers a year talking about the cloud. The remote use of servers to store the information you deal with. And if you look at the Internet of Things, an even more rapid rise. We've had about 5 years ago, there was no mention of the Internet of Things. Today, about the same number of articles as you see about the cloud. Now, what has changed? What has made for the Internet of Things? Well, if you go back to the turn of the century, 2000, we had the Internet, but the Internet was connected to people. You had your personal computer, which once was isolated, now it was connected, and the connections were predominantly computer to people to Internet, and about 85% of all Internet connections were associated with a person. Move ahead, 2005, we hit the equalization point, where half of all Internet connections were not indeed associated with people. They were associated with machines, things that were communicating across the Internet. And by 2010, we were at 75%. Today, over 80% of the Internet connections are to things that are receiving or sending data, information, but other than individual people. Well, what are they sending? They are sending voluminous amounts of information. An commercial airplane, for example, generates 10 terabytes of data every 30 minutes. Well, a terabyte of data, that's 10 to the 12th bytes. Everybody knows a kilobyte, 1,000. We have megabytes for 1,000,000, 10 to the 6th. Gigabytes for 10 to the 9th. Terabytes for 10 to the 12th. And then 1,000 terabytes is petabyte. Yeah, and 1,000 petabytes is exabyte, yes. And how about 1,000 exabytes? Zettabyte, yes. And now, what do you suppose is the largest prefix defined by the International Standards Organization? 10 to the 24th has the prefix yada. Yes, you've heard it. You use it. You say yada, yada, yada. That's, hey, that's a whole bunch of stuff, 10 to the 24th many, many times. Well, we will be at yottabytes sometime, but still, terabytes, phenomenal amounts of information, 1,000 billion, a trillion. Even an oil refinery needs about a terabyte a day, and other major manufacturing operations are continuously transmitting information on their health, their activity. What they're doing allows us to keep them safe, monitor their output, their progress, and so on. Well, it's not just inanimate objects. After all, humans are now becoming creators of information for the Internet of Things. So maybe you have a Fitbit monitor and you get to look at the number of steps you take, and you like to compare that to the number of steps your friends take. So you let it transmit over your cell phone and you do that comparison, and over time you probably have more and more things to monitor as you get older. Maybe your blood pressure, your various sensors that monitor your health. Things like maybe a diabetic has an insulin pump, and so this is all tied to the doctor's office through the internet, and we have a server somewhere, and it lets your doctor get that information, or it lets a computer monitor that information, and that's a good thing for all of us. The problem, of course, is you would like your doctor to have that information, but you really don't want other people you don't know to have that information, and it's becoming increasingly possible for them to do so. And it goes beyond humans. It includes animals, for example. So cattle now have tags that allow the farmer to or rancher to monitor them, know their position, know where they are, even know whether they are sick or well, whether they are pregnant, things that the rancher needs to act upon, all done with sensors, transmitters, communication. And we've even seen that if you want to, you can automate your sprinkler system. You can connect it to the Internet of Things. Your sprinkler can check and see, check the weather forecast. After all, you don't want to water your lawn if it's going to rain this afternoon. So intelligent sensors are available. Sensors for the grass to see how moist is it, does it really need to be watered, and if so, how much should I water it? Of course, it doesn't take as much computer intelligence. If you live in Oregon, you just turn it off in October and turn it back on in May, but it's useful in some parts of the country. Well, this buzzword Internet of Things has taken off so much that in fact on April 9th last year, there were 27 simultaneous conferences and expositions just on the topic of the Internet of Things. And not far behind the IoT, we have cybersecurity, and in some ways they are related. So cybersecurity wasn't a big deal before. It's a term that's been around a long time. It's from a Greek word that means to control or manage. And as long as PCs were largely Windows PCs, things were fine. But now everybody's connected, and we've had an enormous takeoff in recent years, and now we're over 100,000 articles appearing each year about cybersecurity. And we have other kinds of conferences on cybersecurity. One of the most famous is the Black Hat Conference. Now, the Black Hat Conference, as the name implies, is where the bad guys get together to exchange ideas for how to hack computers. And they have really remarkable demonstrations. They had in 2010, they had a person come up and challenge them to hack into an ATM. They did, in fact, within the required time, and it was spitting out $20 bills, and then they demonstrated that he could, 90 feet away, he could affect an insulin pump enough to inject in a dummy an excess dose of insulin. And then you have all these other people, various events going on, how to hack into cars and control systems, and even the hackers of the future, hobbyist hardware available. And I'm told, although I haven't attended, that if you go there, the way you can tell the hackers from the feds who also attend the conference, and the people from NSA and FBI and other places are free to attend and do so, but the hackers are the ones with the piercings and the tattoos and ponytails, and you can guess that the NSA people are in suits, and it's a very eclectic mix of people, and it's that way intentionally, because 1 week apart from the Black Hat Conference is the parent of that conference. Black Hat was spun off, so there would be a conference where the good guys and the bad guys could get together. Well, not really. So the Black Hats and the White Hats could get together, but there is a conference called the DEFCON Hacking Conference, and here the attendance is much more restricted. In fact, in some years, they don't allow the anti-hackers in at all. It's an interesting conference because you have to pay for your admission in cash because they don't want to leave a trail of credit cards around. They understand what can be done with credit card data. And so it's a very anonymous conference, and they also have their own hacking specialties, all unique and exchanging new ideas. Well, we have all these things, the cloud, we have IoT, we have cybersecurity, big new fads going on, conferences everywhere, and if you wanted to fill your calendar by attending any of these conferences, cloud computing, Internet of Things, and cybersecurity, you could in fact attend a conference every day of the year except 8 days and do no work. We're filled out here. So, what's all this have to do? How are these related? Well, first of all, the existence of the cloud, massive server farms that are remote from the actual creators of data, has now exposed data to the opportunity for security threats. And at the same time, the Internet of Things now creates voluminous amounts of data, trillions and trillions of devices that are sending out data that now ends up in the cloud. And at the root of all this are the chips that end up in the sensors that transmit the data, they are in the computers that do the data processing, and they have been the most secure trust zone of the whole infrastructure. And what we're going to talk about tonight is how, in fact, that will be the next frontier of the hackers, but also the next frontier of protection from the threats that are caused by lack of cybersecurity. Now, there is a law that's referred to as Beckstrom's Law of Cybersecurity. And what Beckstrom's Law says is that anything attached to a network can be hacked. Everything is being attached to networks, and therefore everything can be hacked. So I attended a meeting of directors of corporations, and there was a former Joint Chiefs person from Boeing, and he gave a talk and he said, well, there are two types of corporate executives in the United States today. There are those who have been hacked and are taking appropriate actions to protect their corporations, and then there are the ones who don't know they've been hacked. It's going on, and it's a big business. There are a lot of dollars involved. If you look at the estimates by the third parties, they talk about the Internet of Things going to become, anywhere from $700 billion up through 19 trillion. I think that's a pretty likely to be an exaggerated number. That's about the same size as the total U.S. economy today. Cybersecurity, a little more conservative numbers, anywhere from 75 to 155 billion, but a lot of money being spent. And why are people spending all this money? Well, take an example most of you have probably heard about, the Target stores of a couple of years ago. So the hacking into the Target point of sales systems led to a 30% drop in business right after the hacking occurred. The credit and debit card data that was stolen in a relatively brief period of time, a couple of weeks, about 40 million different credit card numbers, 70 million records with customers' names and addresses and other information. And in the next quarter, the profits of the company dropped 46%. The cost, $200 million just for reissue of all the credit cards, $100 million to upgrade the payment terminals. And the fact is that Target didn't have a defect in their system. They gave the passwords to a heating and air conditioning contractor who had a gateway through their system, and so they got into the system, caused the problem, and really enormous dollars involved in fixing it, not to say nothing of the loss of customer confidence. Other things within the last year or so, architects and a lot of other people use AutoCAD software. And someone loaded a template that was very popular and used widely. And the architects found that their drawings, all of that information, the designs of houses and buildings and stadiums and other things, was being transmitted without their knowledge to China, to South America. And so it doesn't give you a good feeling when you know that these people have electrical diagrams, all of the plumbing information, everything else associated with the building, and it occurred on a very broad scale. We have some other notable data breaches in recent times. The Associated Press Twitter account was hijacked, and it reported that President Obama was injured in a White House explosion, $136 billion drop in the stock market value immediately thereafter. 3 South Korean executives resigned because their IT contractor stole financial data from 104 million credit card holders. The Syrian Electronic Army hacked into Forbes and compromised 1 million accounts. The Anthem Healthcare had a cyber attack that allowed access to the personal information of 80 million people. And we have the IRS reporting that it was hacked for 724,000 taxpayers' accounts. So it's getting to be quite a frequent thing. We have smartphone apps that get into the hacking game, and I thought I'd just give a little demonstration here. Any of you who have an iPhone, why don't you get your iPhone out? I actually switched from Android to iPhone recently, but I'm sure you can do the same thing on an Android. Just press the settings button there, and then the general one, and then look at storage and iCloud usage. So we got general, and then storage and iCloud. And is everybody with me? You got, okay. Then look at manage storage. You got that? Press manage storage. Look down at the. Yes. Why is this not working? Okay. Man. Supposed to see my apps. Okay. Oh, wrong one. Okay, see how that works. Good. So manage storage. We'll go down. Look at your flashlight app. Okay. Now, I have went to a presentation where they a group had analyzed flashlight applications on cell phones, and what they had found is that many of those applications are doing much more than lighting the flashlight. In fact, if you look at your flashlight app, I can tell you that 100,000 bytes are required to turn on and off the flashlight. So 100K bytes. Now, how many bytes do you see in your flashlight application? Anybody got one? How much? 2 megabytes. 5 megabytes. Let me tell you what mine has. It's 26.9 megabytes. Anybody got more? So you have to ask, wait a minute, we're turning a light on and off. Why is it using 29 megabytes? And the answer is that it is doing a lot of other things. There was a app creator, a flashlight app called Brightest Flashlight, just a couple years ago was charged by the Federal Trade Commission because their flashlight app, unknown to users, was sending data and to advertisers as a way of taking your information and behavior and making available to others. And the app was downloaded 50 million times. So the group that presented on this had looked at 15 of the apps, and every one of them did things other than turn the light on and off. How many cases of data breaches? Well, in the first 6 months of last year, about 245 million sets of data records lost or stolen. And there is another good example. The remote control on your television. If it's more than about 2 years old, this is very true in Europe. This standard is not as prevalent in the US, but there is a smart standard that connects the TV to the internet. And it's called HBB TV. And in fact, it has a flaw in the protocol. And while that has now been patched, there's still lots of people with the remotes and that have not upgraded their software. And so it allows a third party to come in. They come into the internet through your local network and get into your personal records through the flaw in the television connection. Stuxnet. This one really got a lot of publicity because, in fact, it was created in Israel. It was used against the Iranian nuclear development program. It was a virus that was embedded in Siemens numerical controllers that were used in the enrichment of uranium. It went to 14 different sites. It's believed to have destroyed at least 2 centrifuges when it was turned on. Very clever bunch of stuff. And the Iranians were set back anywhere from 1 to 2 years in trying to repair the problem. So you must say, boy, those Israelis, that's really clever how they got that into the numerical controllers. After all, they would have had to either cooperate with Siemens or get it in somehow, and that equipment had been purchased by the Iranians. What is actually believed is that the way they got the virus in was through what is called a candy drop. So the candy drop actually has been tested by the Department of Homeland Security, and they ran the test, and what they do is sprinkle USB flash drives in the parking lot of government buildings. Buildings where people with security clearances work, buildings where they have very tight networks. And what they then do, they have found that on average, 60% are picked up and plugged into network computers. As if that weren't enough, 90% of those with official logos were plugged in to the computers. So it's not that hard. Now, many of you, I think, may have seen the 60 Minutes run through on the Jeep Cherokee hack. This is one where they demonstrated coming in through the infotainment system, through a bus that is also connected to the other features of the car. They were able to get into the steering, the transmission, the brakes, and as a result, Fiat Chrysler had to recall 1.4 million cars. And what they did was for those customers affected, those 1.4 million, they provided a software patch. And they delivered it on a USB drive, which they sent to customers through the mail. This quote, "That is the dumbest move I've heard in a long time." So we still have a lot to learn in this whole thing. Now, another one we're going to talk about chips tonight. And one of the things that I guess devious people think about doing is embedding a Trojan or a virus inside a commercial chip. And in fact, that has been done a number of times. A lot of the cases are military espionage, so you don't hear about them, but the Syrian radar case was in fact revealed. Actually published a story about it in IEEE Spectrum. And what they did, they believed that they put the Trojans in off-the-shelf microprocessors that were then used in a state-of-the-art radar that the Syrians were using. This is before the Syrian war. And so it had a hidden back door with a pre-programmed code. And what the Israelis did in this case was, before their bombing raid, they could activate a switch internally which turned off the radar for 1 hour while they bombed, and then turned it back on after they left. Very clever, I'd say. Well, so all these examples say, there's not a lot that's safe. Our whole energy infrastructure, all sorts of safety and security devices, medical, health, banking, transportation, national defense, all this can be attacked and increasingly is attacked. So a lot of things to worry about. There are also, however, some benefits to hacking, if you don't mind violating copyright law. Here I show you the Audi S4 Quattro. And this car sells for almost $25,000. Notice 4.2 liter dual overhead cam, all-wheel drive, so on. This is an Audi RS4, not an S4. It sells for almost $40,000. Well, you notice it's also a 4.2 liter V8 engine, dual overhead cam, so on. So why do people pay $40,000 for something that has same engine, same exterior and this as the $25,000 one? And the answer is that it's got really a sporty speed shifting set of gear ratios in there, which in fact are programmed into a memory in the car that makes this car very different from this car. Well, I have already talked to one of our employees who bought one of these and turned it into one of these simply by hacking the electronic control unit. So what else? Okay. So let's move to the vulnerability from software to silicon and look at where people are doing all this stuff today. So the attack types that most of us are subject to are referred to as phishing or baiting, whatever. They're in the applications. We download something from the internet, and then it has in it an enclosure. We foolishly click on the enclosure because it said it came from Aunt Mary, and we just didn't think about it. And all of a sudden now we have a virus on our computer, and all sorts of strange things happen. But you think about it, the person who is causing that problem is sending emails to individual people, so it can affect hundreds, maybe more, but it doesn't affect the whole world. It's very specialized. If you can get into application software, put it into Microsoft Word or Outlook or some other application that a lot of people have, then it can now permeate tens of thousands or even hundreds of thousands of people. But now, of course, Microsoft has large teams of people that are looking for these things at all times, and they, in fact, will declare an alert when they find a bad one, and they will pretty quickly fix it. And if you click on that thing at the bottom right of your screen, you can download the patches that come out every few weeks. But there is a level that becomes more difficult, and that's the operating system. So whether it's iOS or Windows or something like that, once you get into the operating system with a virus or a Trojan, it becomes very difficult to detect and to do anything about. So here, you're now affecting hundreds of millions of people. Now, the one that really hasn't appeared very much, but ultimately will be the real challenge and the real danger, is getting into the hardware itself, into the printed circuit boards, the electronics, and eventually into the chips. And there you can affect billions of people, and you can cause a lot of damage if you want to. So where are people spending their money to protect for cybersecurity? Answer is mostly at the top level, mostly software, network software, or applications or data or other things, that's where the majority of the money goes. The amount spent on protecting physical hardware is relatively small as a percent of the total. Well, what are the challenges that are going to occur, and how do they work as the world moves further and further down those layers into the silicon itself? Well, first of all, the design automation industry is an industry that provides the software for designing those chips, for putting together the logical functions that end up in silicon. Mentor Graphics is an electronic design automation company, one of the 3 largest in the world. And for the last 35 years, people in Wilsonville have been working to help designers design, create the electronics, and then verify that it does what it's supposed to do. Increasingly, the majority of the work is in verifying that the chip you designed does exactly what was specified and does it correctly. And as we're moving into this era of silicon security issues, more and more those designers are being called upon to go beyond verifying that a chip does what it's supposed to do and attacking a much tougher problem, and that is verifying that the chip does nothing that it's not supposed to do. Well, this problem is definable and quantifiable. It's still a very difficult problem and requires millions of hours of computer time, but this problem is totally unbounded because you don't know what you're looking for. Well, the way this problem manifests itself is in really 3 different forms. So the first one I'm going to talk about is what are called side channel attacks. So let's say you have a silicon chip and you want to get information out of it. How, for example, the chip in your credit card, for example, if you've gotten a credit card with a chip in it, and somebody wants to get your PIN out of there, how would they do that? Is it really secure? And side channel attacks deal with the issue of extraction of information, not just from chips, but in general. And it's the defense against attempts to leak secrets stored on the chip. And if you think about side channel attacks, the analogy is the person with the stethoscope who is trying to figure out the combination to the safe by listening to the tumblers fall. Very primitive safe, but in fact a way to, without destroying the lock, you can get the combination. Well, you could also do that remotely by simply thermal imaging. If you could get a camera and just look, you could see what numbers are being pressed. But in the chip world, side channel attacks end up really mostly in a couple forms. So there are passive attacks, and they usually involve one of 2 things, either power analysis or electromagnetic analysis. There are also active attacks, which are much more efficient, but there you have to get a little more sophisticated and inject faults into the chip. So how does this work? So let's take a look at the power analysis. What people do is based upon the fact that a thermal image of a silicon chip will show higher temperature wherever there's lots of electrical activity. And so you take a movie of with a thermal imager, and then you connect the chip electrically and you enter a bunch of data. And you monitor what's happening, and you will see different power dissipation patterns. And what you can do then is analyze those patterns, and by entering different keys, you can see which parts of the decoder creates a hotspot, and over time, you can in fact infer what the pin is. And this is done more frequently than you would think. Another way, I meant to mention, is you can do this with radio frequency emissions as well. The chip gives off RF, and so you can monitor it. And in fact, the people who do those credit card chips change the algorithms about every 12 to 18 months because people get more and more clever in how they're able to read them, and so they have to make them more and more difficult. Well, you say, gee, getting credit cards, that's a hard way to make money, even if you're a thief. So what might you do? You could, in fact, do e-passports or hack into people's mobile communications. But actually, one of the best money generators for cyber criminals is in digital entertainment. So all that money you pay to the cable company for local television could be avoided if, in fact, you knew what the signal encryption was with the particular set-top box you have, so that you didn't have to pay that monthly fee. Well, it turns out that there are people who, in fact, do exactly that, and they sell the unlocked set-top boxes. So if you go to eBay and look under set-top boxes and look very carefully, especially the ones from China and other places, you will find that they have set-top boxes that are unlocked. You plug them in and you watch all the TV you want, and you never get that troublesome bill from the cable provider. Well, it turns out that the people who design these boxes understand that this happens, and so we met with some of them, and interestingly, they told us that they have an 18-month goal. That is, whenever they release a new set-top box, they then measure the time until the unlocked version shows up on eBay, and 18 months is really good. 12 months is more common, and so if somebody comes to your door and says, how'd you like to buy an unlocked set-top box, you know, he's just trying to make a living getting around the law here. Well, other people have come up with innovative approaches to how to get your password out of your cell phone. The latest one that's shown up is one that uses the camera. They hack into your camera and the microphone, and then every time you enter your PIN, they monitor either finger motions or sounds, and they get your PIN, assuming you have something of value within your cell phone. Well, all of this can be limited in many ways. There are lots of things that you can prevent side channel attacks with, and you don't have to be that sophisticated. It's sort of like the club you get to lock your car, and they could probably cut through it with a hacksaw, but why not steal somebody else's car? It's the same principle here, like the old story of the two men on the camp out, and they see a grizzly bear coming, and one of the men says, gee, we're never going to be able to outrun him. A grizzly bear can run 30 miles per hour. And the other guy says, you know, I don't have to outrun him. I only need to outrun you. Well, it's a basic principle. You just need to make it more difficult than your competitor makes it. So what's going on? There are lots and lots of companies springing up whose sole business is to protect you against this kind of intrusion, particularly side channel attacks. Cryptography research ends up selling software into a very large share of the cell phones in the world in order to protect them from this differential power analysis I showed you. If you look at the different ways these companies do this, one way is you have a signal like this, and they will put on top of it a lot of noise, so it's very difficult to filter out the actual signal. In many cases, for cryptography, instead of entering a PIN in successive digits in a register on the chip, they'll incorporate randomness and put one bit in one place and one in another, and then a code to allow decoding of where the bits actually are. And there are people who actually dissect chips, section them, and try to find the stored bits in read-only memories. And for them, there are ways that they can be camouflaged. So there's a lot of activity to prevent the reverse engineering. But as I noted, it's where there is a desire, there is enough innovation to overcome some of these effects. So what are people doing in the future? Well, we're getting more and more devices. People are putting sensors all over the place, and by 2020, 80% of all cars will be connected to the internet. And we have a new standard that's pretty stable and being propagated for how your car will communicate with every other car to tell its position, velocity, and other information. And so increasingly, that has to be, that information has to be utilized and not fooled with. So it means hardening of the circuitry, protecting it against intrusion, but also it means that cars are being designed differently. So the car that I showed that was hacked into, one of the problems was there was no separation between the information and entertainment or infotainment part of the vehicle and the fundamental steering, brakes, and other activities. Future cars produced will have good isolation, but realistically, they will ultimately have to have wireless download of patches for software because it's just too difficult to design software that is non-hackable. And so the next best thing to do that is to have a vehicle where you can download a patch to the software in 24 hours after the bug is found. And that, in fact, is what Tesla has done. Let me move to our second level of security concern. And this one is another moneymaker for the criminals. It's counterfeiting chips. And here we're talking about detection of overproduced or cloned or recycled or remarked or otherwise unauthorized chips in the market. How big a business? Well, electronics as a worldwide business is $2.5 trillion. That's about 15% of the US gross domestic product. And so it's a big business, and within that, the semiconductors, the chips, are about 15% of that number, or about $350 billion per year. So a lot of chips are sold. So a lot of people have decided they want to get in on the action, but they're not really interested in designing chips. So they take another approach. And so counterfeiting has become a significant business. And there are a lot of misconceptions about that counterfeiting, how significant it is. For example, most people think that a counterfeit chip is very unlikely, 1 in a million. In fact, independent distributors say that between 0.5% and 35% of the incoming product is suspected of being counterfeit. Only bad distributors sell counterfeit components? Not true. Actually, most are sold through authorized distributors who simply have no way of screening what's a counterfeit and what isn't. Only expensive components are counterfeit. No, the market has made its way down to $10 or less parts, and you just have to sell a lot of them to make enough money, but 60% are $10 or less. And lastly, that the counterfeit parts will be detected by electrical tests. Actually, it's not true. More than half, in fact, test correctly, but may, in fact, not operate in the mode that's fully specified. This is a company, IRI, that keeps track of reported cases of counterfeit chips. And you can see this goes back to January 2009 up through the present. And there's been a steadily increasing trend in the reported cases of counterfeit chips showing up in equipment or in the market. 80% or more of the counterfeit components are either discontinued or end of life or not recommended for designing. So what does it mean with a discontinued chip? When a semiconductor manufacturer manufactures chips, over a period of time, the chips become obsolete. And so no one is designing them into new designs, but they are still buying them for producing those, whatever they designed them into. And so at some point, it becomes costly to maintain these, to maintain inventory tooling and so on. So the semiconductor company just says, you know, it's end of life. Come, if you need to buy more, buy them. We'll give you one chance to buy, and then we're going to discontinue it. Well, the people who are most affected tend to be military, aerospace, others, where the equipment was designed, has a very long lifetime. A C-130 transport, for example, or cargo plane, was introduced in the 1950s, and it's still in broad use. They keep upgrading the electronics in it, but these things have a very long life, and the semiconductor manufacturers aren't very patient. Now, it is true that end of life is sort of a euphemism. I used to run a major semiconductor business, the Texas Instruments one, and if we were having a tough year, then along about December, when we were looking for innovative ideas for how to generate a little extra revenue, someone would always say, why don't we run an end of life on a couple of these parts? And then these people will come in and they'll have to, hey, I need to buy 20 years worth of parts because they're end of lifing them and I won't be able to buy them. And so they would come in and buy a whole bunch. And we could generate enough extra revenue to make it through the quarter. One thing we found was, of course, we still had some inventory. So next year, when the same problem came around, we ran another end of life. And people started to get suspicious on about the 5th or 6th end of life. But eventually, we did run out. We didn't have any more chips. And now these people are forced, if they didn't buy enough, to go out and buy them in the gray market. Well, there's a report recently, an indictment by a supplier operating out of his bedroom. They found 13,000 parts in his bedroom, based in Hong Kong, sold them through a distributor, ended up in a U.S. nuclear submarine. A little scary there. You're controlling your nuclear power plant in the submarine with counterfeit chips. So it gets people's attention. And you say, boy, why can't they keep better track of those chips? The answer is because if you gave semiconductor chips frequent flyer miles, they would exceed everything that we get. They travel all over the world. This is a case study done for the Joint Strike Fighter. And you can see the chip is designed in one place, then it's manufactured and packaged. So if you design it in the US, it's probably the wafer fab is in Taiwan, and then you send it to Manila, Philippines, or somewhere to assemble it. You may send it back somewhere else to test it. Then you send it to a distributor. It's put into a piece of computer equipment. That equipment printed circuit board is manufactured in Asia. It's sent back to the US and so on. These things go all over the world, and it's just very hard to keep track of them. So if you look at how the chips end up in the system, it's one of a number of ways. One is overproduction. You have a subcontractor, they are producing parts for you, and incidentally, they produce some extra parts, and they don't tell you about them because, after all, they can sell them in the black market. Supply chain manipulation, where someone is in the supply chain and able to siphon off good parts or get bad parts into the system. Failed or low-grade parts, remarked. So this has been historically a very big problem in the semiconductor industry. The reject bins for the devices that fail need to be controlled, and people try to get hold of them and then sell defective parts. Or the last one, very interesting, recycling. So how does the recycling work? Well, with recycling, we now there are estimates that recycled ICs account for 80% of all counterfeits. And the way this works is there is the regulations in the U.S. Now say that for environmental reasons you can't dispose of a computer equipment by just tossing it in the garbage, because after all it contains lead and other noxious materials. So when you have old computer equipment, you sell it to a recycler. They ship it from the US to some third world country. There they break down the computer equipment, take out the printed circuit boards, and incidentally they have a little side business in some cases where they take the chips out, they polish them up, refurbish them, repackage them, and then resell them, and they end up coming back to the US all shiny, new, as if they had never been used, but in fact they were used for 20 years in the computer before you in fact threw them away. So what are some of the clues you can find? Well, you can see if the company isn't that careful, the leads may be tarnished, or you'll see double markings or part numbers that aren't right or serial numbers missing, those kinds of things. And for more sophisticated integrated circuits, you'll see the parts that look alike, but in fact they aren't. So anybody want to guess which is the counterfeit? The right one? Anyone think the left one? Okay, there we go. So, how would you know? This is a Cypress semiconductor part. There's the Cypress tree. But you know, this one is straight and clear and nicely done. This one is crooked and smeared and so on. It's the good part. Well, okay, since we'll give you another try on this. So these are just old standard power transistors. Here we have a set. Any guesses on the counterfeit? How many for the left? For the right? Okay, we've got people on both sides. There we are. Well, once again, this one's really easy to read. It's nicely done. Okay, well, enough of this. This one's actually the toughest of all. This is called tape and reel. This is where the components are on a piece of tape, and these are individual chips. And you look at those, and you say, hey, they all look right. You know, could there be counterfeits? And the answer is, if you look at them with X-rays, you find that some of them have real chips and some of them don't. Somebody is saving money just putting fake chips into the tape and reel. Okay, well, the components end up in equipment. So 35% of them were not discovered until they actually made the end product. So this is looking at if you're in production or after launch of the product, it's all this area here. So over a third, and that's very costly to come back and take them out of the equipment. And worse yet, it's a safety hazard or a problem in the functioning of the equipment. How do they find them? The largest reason is they're returned as defective because they don't operate properly, or they work, but they work with poor performance. That's what happens when you get the reject bins and get them into production, and then they show up for other reasons. So what can we do about counterfeiting? Well, there are things that are done. There are precautions for high-risk parts. So people who are building safety-critical equipment, military people and so on, carry proof of traceability, rigorous test methodologies, chain of custody control. But all of that is very, very expensive. And there are other things you can do, even more sophisticated technology. There are things called puffs, or physically unclonable functions, that you can characterize a silicon chip by the way its memory starts up. But the fact is, it's very expensive. So if you want really good security, you can get it at a price, but most people elect not to spend the money. And so most chips in the world today are not protected in any way from counterfeit. There's a standard proposed by the Defense Advanced Research Projects Agency that would put an identifier into the package, but it costs about 10 cents a chip, so people are not really interested in paying it, so it's been very slow to take off. But there are some things you can do at the design level. So think about the recycled computer equipment. What you're worried about is the chip has been used for 20 years, and chips do wear out. The electrons going through the metal carry some metal with them, and over time they will fail. So what design companies like Mentor Graphics are doing are providing our customers with design logic they can insert in a chip for on-chip odometers, where it actually tracks how many clock cycles have been running. Has this chip been used for 20 years? If so, you need to know about it, and they can embed that in a chip. Another way to do it is simply design the chips where it requires an activation code, and therefore only an authorized person can use it, and if it gets into the wrong hands, then they're unable to do anything about the activation. Well, so the overall problem is sort of similar to the one we face with virtual private networks. You have data, you want to get to a user, and you have to go through a very insecure internet, and we set up private networks in order to do that. Well, it's the same thing here. The world is evolving to a system where you can design chips and, in fact, transmit the data and information without corruption and without third parties, and transfer the chips as well through a supply chain that's unreliable and get to the final users. Let me move to the last one. Oops. The malicious logic inside the chip. And this one is the toughest technical problem. Here, you need to detect, is there something bad inside the chip? You can either do it by operating the chip, or you can do it at the design phase. But it's not easy. Trojan detection is difficult because you really don't know what you're looking for in many cases. So what we call semiconductor IP, or design information, ends up in chips. That is, when you design a chip, you reuse a lot of the design that you did last time. You go to third parties and you buy little blocks of intellectual property or blocks of design, and then you create some of your own. And if you just track where does all this stuff come from, it comes from everywhere. And some of these places aren't too reliable in terms of the design information they have, and there may be Trojans that sneak into the chip from that source. What's a Trojan? It's rogue hardware that's injected into the chip, and it can be triggered by a special event at a specific time, by getting a signal that's sent to it, like the Syrian radar, and you can either disable the chip, or you could covertly access confidential information, or do whatever you want. And this is not imagined, this is in fact going on. And if you talk to people who worry about this kind of thing and worry about the security of their own equipment, hardware Trojan detection and prevention gets to the top of the surveys for the thing they worry most about. Well, so why is it so difficult to detect a Trojan in a chip? And the answer is just because the chips are so complex. Millions of nodes in a small chip, billions of states, electronic states, that a chip goes through, and test time is very expensive. Testers cost millions of dollars. A typical complex chip that may sell for $10 or $20 probably has 10 or 15 seconds, maybe as much as a minute or two of test time, and you really can't tie up those testers too much of the time. And besides that, the only tests you can write are for known causes. So you're looking for a Trojan and you know what it looks like. But in fact, that's not the case that you're most worried about. The case you're worried about is the one where you don't know it. So there are millions of chips, and they have to be, they're not all fully tested. They do some lot sampling. And in the design phase, it's just impossible to do all the simulation. And as I said, the unknown unknowns are very, very difficult. There's a thing called formal verification where if you know what the Trojan looks like, you can find it in the design. If you don't know what it looks like, you have to resort to other techniques. What techniques? Well, the one that is just coming to market now is the ability to insert in the chip a monitor. And the monitor looks at everything going on in the chip and looks for unusual events. The analog here would be if you were flying in a helicopter and monitoring the traffic, you would see a normal flow of traffic. But if all of a sudden you saw 100 cars all together speeding down the highway, you would say there's something fishy going on here. And it's the same thing here. This is a snooper that looks at all the transactions going back and forth from the internal processor in the chip and identifies when some or a very unusual combination of operations occur. So, let me summarize. First, there is a hierarchy of threats. We are moving down that hierarchy, and today most of the activity is up here at the user application level, and in the future, the sophisticated hackers are going to work down here. You, in fact, may have read stuff about the US government essentially putting a ban on Huawei telecommunications equipment in the US. Largest manufacturer of telecommunications equipment, used all over the rest of the world, not the US, because it's suspected that the Chinese might put Trojans into the equipment, which could bring down our infrastructure, communication system, and so on. Well, our people have met with people at the National Security Agency, FBI, all these agencies, and asked them, is this really a problem? I mean, after all, I've never heard about things happening. Why are you prohibiting this equipment coming in? And they just look at you and they just, smile and say, it's okay. And what I have finally concluded is the reason they know that this is going on is because they have been doing it for a long time. Okay, so we have hardware as the root of the whole infrastructure of the Internet of Things. All those sensors are based on chips, all of the data processing that goes on when the information comes from the Internet, and so it forms an infrastructure that has to be secure. Well, so what's going to happen in the future? And this is my speculation of what I think will happen. I think that there will be emerging customer demand for silicon authentication. After all, people who manufacture medical equipment or military equipment or other things in safety applications are going to become more and more concerned that the silicon they buy is in fact secure and contains no undesired Trojans or other viruses. I think before long, the importance of new standards will permeate so that people who want to meet those standards will increasingly force the validation on their semiconductor suppliers. And there are a bunch of them. Most popular new one in the automotive industry is ISO 26262, and it enforces a lot of design practices on the designers of vehicles, which they then force back on their suppliers. But lastly, I think for it to be a really effective, there needs to be, or will be, doesn't really need to be, but what's likely to happen is like 9/11, you'll have a major publicized silicon security issue, someone will be injured or financial damage will occur, and then I think the world will become much more sensitive to the issue and we'll see a major change in the way the semiconductor industry works. I would expect that semiconductor customers then will require certification of the chips they buy from their suppliers, and they will pay accordingly. The chip suppliers will scramble to test and certify their existing chips. The procedures implemented to screen design blocks used in designs, this is difficult because you're getting those design blocks over the internet from a lot of unknown sources, but more and more those will be screened. The design methodologies will be modified to add the kind of countermeasures I discussed, and Trojan detection and prevention will become a design process for the electrical engineers and other scientists who do the designs, and it will be yet one more task that's part of the verification process to assure that the chips, the silicon that's sold is in fact secure, is not introducing safety issues, and is resistant to hacking by people that should not be getting into it. Thank you.